So now we have an understanding of what it means for an operator to be linear. So let's now extend that to an equation. So what does it mean for an equation to be linear? A differential equation is linear if its associated operator, and what I mean by that is if you put all of the y terms, or if it's a differential equation in U, all of the u terms on one side and everything else on the other side, the operator defined by the left-hand side is the associated operator. So a DE is linear if its associated operator is linear. And so let's see what that means for our equation. We had the equation y times y prime plus 3t squared y equals sine of t. Now we've already figured out that the operator is not linear because of this term here. This one would have been okay. This would have still maintained linearity, but the y prime term was the problematic one. So the operator is not linear, so the differential equation. So this equation above is not linear. And again, just like the 3t squared did not cause problems for linearity, this term on the right-hand side doesn't cause any problems either. And we call the expression in this case sine of t, but in general the expression on the right-hand side, the one that has no y terms in it, the expression sine of t on the right-hand side is called an inhomogeneous term. Now, if you remember having heard the word inhomogeneous in your linear algebra class when you talked about ax equal b, b was the inhomogeneous term. That is exactly the same notion, but that may not be obvious to you at this point. But we will see that throughout the course. So an expression sine of t is always called an inhomogeneous term. And the equation, let's make that definition. And the expression, so the DE, and this is another point of classification, is an inhomogeneous equation. Oops. If the right-hand side is 0, we call the equation homogeneous. So just a general comment here about what's expected of you. So in this course, I don't expect you to go through this entire calculation of checking linearity whenever I ask you if differential equation is linear or not. But at times, you might find it necessary to do that, to fall back on that definition. But there are some shortcuts that you can use once you've done it a little bit with the definition and get a grip on what types of terms make an equation nonlinear and what makes them linear. Since we have a little bit of room here, I will do a few examples. So let's say we have y prime plus t squared y equal 0. Is this linear or nonlinear? I can give you a second. Okay, good. Thank you for thinking. Linear. Homogeneous or non-homogeneous? right? Good. Thank you for thinking. Again, lots of thinking going on, right? Homogeneous. This one is homogeneous. So linear because there's no product of two y's or y squareds or anything that would cause linearity to break. And homogeneous because when I put all of the y terms on one side, there's a 0 on the other side. So let's try this one. Let's say we have sine of t times y double prime plus cos of t times y equal t cubed. So this equation, linear or nonlinear? Okay, so this one is also linear. It's, let's see, let's go through the full classification that we have so far. It's a second order ODE, and it's linear because there's no nonlinearities in any of the y's. There's no products of y's. I never take the sine of y. Yes, there's a sine of t and cos of t, which are nonlinear functions of t, but they do not make for a nonlinear operator in y. So that all comes out linear. Now, if you're unsure about any of these, you can go back and plug these into the definition, and you'll see that you have the additive, that's condition A, and you have the scalar multiple condition, that's condition C, condition B, that involves that c times y. And finally, there's a t cubed on the right-hand side in these. So this is a linear but inhomogeneous differential equation.